Question 1 asks, explain how Boyle's law and Dalton's law are related to gas exchange in the human body. Boyle's law states that volume and pressure are inversely related. This means as one increases, the other decreases. This is important in discussing how ventilation or the mechanical process of breathing in and out in our body works. When we inhale, our diaphragm contracts or it flattens, allowing our lungs to increase in size or volume, therefore decreasing the pressure in our lungs. This is important because gas likes to move from a high concentration to a low concentration. And when the atmospheric pressure is at 760 and our intrapulmonary pressure is now lower because of the increase in volume, now it's at 757. So gas wants to move from the 760 to the 757, which allows us to inhale and bring air into our lungs. Now when we exhale, our diaphragm relaxes, which decreases the size of our lungs, therefore decreasing the volume in our lungs, and increases the pressure in our lungs. The pressure now jumps to 763, which is greater than the atmospheric pressure that's at 760, which allows the air in our lungs to exhale and go back into the atmosphere. Now, with diffusion or the movement of gases, specifically O2 and CO2, that involves Dalton's law, which states that the total pressure of a gas mixture is equal to the sum of each pressure that is exerted by the individual gases. So in this case, we are talking and focusing on CO2 and O2 because we breathe in oxygen and breathe out CO2. So what happens is when the partial pressure in one area is higher than the partial pressure in another area, that molecule want to move from the high concentration to the low concentration, similar to inhalation and exhalation. So for oxygen, when we have a high partial pressure of oxygen in our arteries and a low partial pressure of oxygen in our muscles, oxygen wants to move from our arteries to our muscles. This is important because oxygen is used to fuel our muscles with the energy that it needs to keep contracting and therefore keep our body moving and functioning. Similar is with carbon dioxide, is the partial pressure is higher in our veins than in our lungs. So CO2 wants to move from a high concentration to a low concentration. So the CO2 will move from our veins to our lungs, which is important because when CO2 moves into our lungs, we can then exhale it because we don't want CO2 anymore. And the most important thing with Dalton's law is that the greater the difference in partial pressures, the greater the amount of gas exchange that will occur. This is super important when we are, say, exercising because we want those greater partial pressure differences in order to have more gas exchange because we want more O2 delivered to our muscles to fuel them and to have enough energy to keep going with the demand that's being placed on our bodies for exercise, as well as we want an increase in CO2 being exhaled or leaving our body because that sends signals to our brain to then continue to keep breathing and continue to keep bringing in oxygen to fuel our bodies.